All right, thanks. Yeah, thanks for having me. I hope this isn't too much of a bait and switch. I actually will talk about D3 and large scale visualization, but I think since I was asked to speak about that topic, I broadened the scope a little bit. And first of all, I want to say I'm really excited to be talking to this group of folks. The work y'all are doing is really amazing and inspiring. And I'm coming with what may be like a little bit of a tough sell. Like we should do more scientific computing in the web browser. But I have some reasons to believe I'm not crazy, and I'll share them with you, and then I'll try to share what I've seen that I'm excited about, and hopefully you walk away with some ideas. So I actually got my start in programming and making Java applets as a teenager for a microscopy website a long time ago. And then I actually went to grad school for as a master's student in scientific computing. And it was a new department, and they brought together applied mathematicians, physicists, material scientists, biologists, computer scientists, all kinds of folks to teach like computational methods. It was kind of like an applied computer science, and so we learned a lot of techniques for simulation, numerical methods, data and algorithms, and I also learned a lot about scientific communication because I was really drawn to the papers that I was reading. That's what brought me into the program, was seeing the kinds of breakthroughs science could make with computation, and then the talks and the posters that taught me things were like really enthralling. But of course, there were some talks, posters, and papers that I couldn't understand. And at the time, I thought most of it was my failing. But I came to understand that like communicating the understanding that we get is difficult, and it's like its own discipline, right? And there's a lot that goes into doing that well. And I also learned a lot about compute environments. And at the time, I thought, in my program, a lot of it was about, data throughput, speed, how close to the memory you are, how many, it was supercomputing. This is actually like before cloud environments really took off and were available. So there was a lot of time and energy spent on getting your environment suitable to like run your experiments or your simulations, and sharing that was very difficult. And right, because like it'd be hard to reproduce this cluster's setup on another person's desktop. But at the same time, these environments were some of them had decades worth of institutional or like community wisdom and knowledge baked in, routines. I had to learn some Fortran or MATLAB, right? And like there's a lot of resources that are already there, so you can focus on doing something new. However, if you learned about something in one area where people used Fortran, let's say, it was really hard to take that over to like a C++ environment, and with a different idea of parallelism and all this stuff. So I became interested in like what makes a good environment, and to the extent that it does leverage contributions from many people have made, and surfaces those. Right, I spent a lot of time porting example or like homework and assignments from MATLAB into Python, and like the sort of exploding amount of numerical tools in Python at the time was really exciting, and so like the more that was there contributed by the community, the less time I had to spend rewriting algorithms from scratch or figuring out how to install some arcane scripts and get them to work on a new data format. And since then, I think that the computing infrastructure has improved and standardized a lot, right? Like we have all kinds of modern software engineering practices, the whole cloud ecosystems and Kubernetes and all these on-demand things that, impact of industrializing machine learning and like, all the matrix math that we've always wanted to do is now like way cheaper and way more accessible, thanks to folks at NVIDIA too, of course. And so that's all a lot more cosmopolitan, I think, is that you can do a lot more quicker. However, scientific communication is still pretty firmly rooted in the PDF, right? So the thing that I'm really excited about and I gravitated to about 10 years ago and have been really excited to see how it's developed is the browser. So, like we all know the web was actually created in a scientific institution to share scientific knowledge, right? But it's still been like kind of a frontier for scientific communication for decades because the computational medium wasn't always there, right? Like, in fact, people, I've jokingly but lovingly referred to it as the lowest common denominator of programming environments, in the sense that everyone has access to this computing environment, right? Whether it's on your phone or your desktop, whatever platform. But since it has to work in all those places, it doesn't do a great job the way that you can when you specialize. But it is very accessible and has also become really powerful and expressive as a medium. And that's what I want to kind of highlight in this talk, is go through a bunch of examples of how I think that's the case, a bunch of opportunities that we may be inspired by and incorporate into the science that we're doing. And I think it allows for a new almost kind of collaboration and sharing of ideas. And so the first thing I have to bring up, and it was in the original title of this talk, so maybe many of you have probably seen examples online. There's hundreds, if not thousands, of examples of D3 data visualizations. It's really powerful. A lot of I've been in this community for almost 10 years. Since I first started learning it, and I've organized meetups in the Bay Area and conferences, and I've got to teach a lot of people and see a lot of projects go by, and it's really inspiring to see like the variety and diversity of things people make and the concepts they're able to express with this library. But I will say that it takes a lot of energy and investment to master this. It's not a charting library. It's not like matplotlib or ggplot or something where you can just say, give me, a scatter plot or whatever chart would be a good fit for your data. It's much lower level than that. It really, in order to master it, you have to master the browser. And there's a number of technologies that you have to at least become familiar with, if not fluent, to really express yourself in it. So before I don't want that to discourage people. I want to be real about that. And first, what I want to do is show what is possible when people do obtain that mastery. Like, let's take a look at some things. Maybe you've seen some of these. Maybe they'll be new. I'll also share the link to this presentation, because like all these slides are links out to more things that really should be clicked through and experienced to get the full effect. And then I'll talk a little bit about ways in which I think you can approach and like get some of the benefits of this without necessarily needing to master a new computing environment and domain, because I know everyone here is busy doing science, and that's a lot to ask. So the first thing I want to call out is Distilled. Distilled.pub is a new kind of scientific journal for machine learning, and it puts an emphasis on communication and in using interactive data visualization as a big part of trying to communicate these, pretty complex concepts. And I had the privilege to work on some articles with the researchers at Google that started this, and it was really eye-opening. The kinds of visualizations, the kinds of text we were able to put together was something else entirely, but it did take a lot of work. And people, across disciplines seem to be pretty excited about the potential for this kind of communication, because you really get to play with the concepts. I think one of the inspirations that, like myself and many other data viz people you might encounter, credit is Brett Victor, who talks about, when we do computing, a lot of times we have to pretend to be a computer. So we pretend to be a computer so we can go through an algorithm, and that's the way we understand and accomplish that. But with this kind of interactivity, you can let the computer be the computer, focus on the concepts and play with the system more from the outside. And of course, if you want to get in and really understand the mechanics of the algorithm, that's always there for you. But I think it's really exciting to be able to make some of these concepts accessible to people who don't have the time, energy, or patience to pretend to be computers in totally different domains or things like that. So, when I share this, I encourage you to check out. These are a couple of articles that I really like. There's many more. This ResearchDead article is also really interesting, I think, in terms of thinking about scientific communication. Another really inspiring, well, I guess it's a tool project, a lot of things that maybe many of you are familiar with, is called NextTrain. For those that aren't, it's, one aspect of it is that it is an interactive visualization tool for pathology genetics research, so understanding how viruses evolve. It was used in the Ebola outbreak 5 years ago, has developed since then, and of course was actually instrumental in the COVID outbreak in identifying community spread in Washington State last March. And since then, it's also it reuses these web-based data visualizations, which are visualizing genomics data that's been shared by scientists across the world and labs across the world. It does mix sort of this offline data processing, which prepares the data for the browser to show you these views, which then help both researchers as well as public health officials understand what's happening. And then they've made these situation reports, and of course these viral Twitter threads by Trevor Bradford, who runs the lab at UW, which have informed quite a number of people on this public health concern that, of course, before that people had no idea about, things like R0 or the general public, I think. That brings us to COVID in general. I know as scientists and many people who know more about this, there can be a frustrating amount of armchair epidemiology and genomics and that sort of thing. However, let 1,000 flowers bloom could be one approach. And if you look at, for example, Zan Armstrong's roundup of the visualizations that have come out of the pandemic, you can see a lot of high quality communication as well as scientific thinking from a number of different places that may not be traditional sources of this kind of thing. And Zan Armstrong helped lead the efforts at Google to do their dashboard that you get when you just search for COVID there. So it's well researched. And there's also a link to this collection of COVID visualizations on Observable, which is something I'll talk about shortly, which has led to a number of interesting scientific communication improvements, I feel, in terms of like, I don't know if you've seen this herd immunity simulation on the Washington Post, but it's an interactive simulation that runs in the browser to give people a more visceral sense of what herd immunity means, right? So that, and this is really coming into play now as vaccines are being discussed often, and this is like a critical public health policy issue. The communication, like the ability for people to get more literate about science and data, I think has been really a good development. And so here, these links are just a couple examples of, I think, good practices in that. So that's where I want to bring up Observable, which it is where I work. It is a browser-based code editor, for short. It's kind of a notebook like system. So if you're familiar with Jupyter notebooks, that's a good mental model to start with. However, it's got some important distinctions, and one of the ones I think that is really important is that it runs in the browser on whoever's computer is running it. So there's no like servers or worrying about these compute environments, right? It's just the browser. And that means that the friction to sharing ideas and collaborating is reduced greatly. And that's what we're kind of focused on trying to encourage and make easier, actually. And so in this slide, I've linked a few notebooks that are explicitly like science visualizations that are, I think, interesting from the perspective that developing them in other environments would be a lot more difficult. And actually this one explicitly calls out how this author tried to do this in 2012 with a different suite of tools, and it was much harder to express the ideas that they were trying to express back then. And so I'll encourage you to click through these for the sake of time now. Another distinctive feature of this platform, which is a programming paradigm that's gaining popularity in different places, but it's this idea of reactive data flow. And without getting too technical into it, the kind of idea you can think of is that it creates some sort of Unix pipe-like ability to put data from one interface element, like a component or visualization, and pipe it into the next. So like this little animation is showing brushing or filtering on a parallel coordinates visualization, and then the resulting, like that subset of data being visualized in a scatter plot. The thing to emphasize here is that like doing that is really easy in this environment, and it's like a really emphasized aspect of it. And what that means is that once you have some kind of way of looking at some data, and I think that like especially in science, it's really powerful to be able to customize the representation to the domain, and like choose your colors carefully, and like get specific about it. Once you have something like that to show your data in a particular way, showing some subset of it or showing a different view of it or linking it to another way of looking at that data becomes almost trivial. And I think that's really powerful, because as we're trying to understand the outputs of our simulations or data sets that we're getting from other places, looking at it in a bunch of different ways, I think, is a key part of gaining understanding. And then, of course, sharing the way that we see it with others. And the last thing I'll kind of pitch here is that it is actually not to try to say you should do all of your scientific computing in JavaScript. There's actually some really interesting efforts to port, sort of NumPy and Pandas type things into JavaScript and make it fast. Like Google's spent a ton of money to make the Chrome engine like almost as fast as like say the Python environment. But you'll never really get to true like parallelism or the scales that we often have to work at. So another a way that I'm hoping people will think more about is to let the environments do what they're good at. So if you get some, if you play around in Observable or in some other, the D3 world, you may find that you have easy access to a lot of interesting ways to look at data, and interesting ways to share that data with other people, right? Like it gets easier to do. And that's what that environment is good at. So then the question is, preparing that data or processing it, computing it, I'd still say do that in the environment that that you know and love, that is good for that, and start thinking more about the interface between them. Like, can you prepare data in a way that it's easier to bring into this world where you can look at it in a bunch of different ways? And there's things that we're working on with the community, like if you build a visualization in Observable, you can actually run it from the command line. And so you could do things like run a Python script and then follow that up by running the visualization script. And I think focusing on the speed of iteration in different environments is a good way to kind of think about that. So, I mean, all that said, JavaScript is, it's fine, I grew up on Java and then Python, and like I said, I had to learn some Fortran, and it's got a little bit of nuances. There's a little bit of weirdness working with the browser, different concepts, but there's not that many. And to get the benefits of this kind of expressivity, I think it can quickly be worth the small investment. And I've linked a couple of tutorials here that you can check out. So that is what I've come to say.